In today's episode, we'll be taking another topic that is very required for you to be familiar with towards the preparation for your UTME exam. And the topic before us is differentiation and application of differentiation. Now, it is very, very important that before you uh, go into your exam or when you are preparing for your exam, you should always review the syllabus, because it is this syllabus that the examiners is going to use to set the question. And over the years, from experience, they do not UTME does not go JAMB does not go beyond the the syllabus. So if you cover the syllabus and you ensure that the stated objectives are what you are confident that you are able to do, then you can go into the exam confidently and you will come out in flying colors. So for differentiation and application of differentiation, these are the topics that you must be familiar with: limit of functions, differentiation of explicit functions, algebraic functions, and also differentiation of trigonometric functions, sine, cosine, and tangent. Also, application of differentiation you should understand how to evaluate rates of change and the extremas, which extremas are called minima, the maxima, and the minima. You should be able to do that. So you can see the objectives. The candidate must be able to find the limit of a function. They must be able to differentiate explicit algebraic and trigonometrical functions. Then under applications, candidate must be able to solve problems involving application of rate of change, maxima, and minima. This is what UTME requires you to know. So if you are very familiar with this aspect, then you are confident that there is no question that will come out uh, from this particular section, okay, that you will not be able to answer. If you have gone through your UTME 2026 scheme of work, you will have seen that this aspect falls under the section 4 of the mathematics UTME syllabus. Section 4 is basically calculus, okay, and the aspect of calculus involves differentiation and integration. This is one aspect, which is differentiation. So, and if you have studied just these concepts under this differentiation, under this under differentiation, then you are very sure that any question that comes will serve right into your hands. Now so this aspect, we are going to be focusing on solving questions. So as we solve those questions, the necessary explanations for you to understand the question and solve any other one that comes around that same concept, you will be definitely be able to solve them. So let's go. Let's start. Now the first aspect is limits of functions. What is limit? So when you are saying you are finding the limit of a function, what are you finding? So limit of a function is evaluating that function as the independent variable approaches or tends towards a particular value. For this particular case, we have y equals to x to the power of 3 plus 6x minus 7 all divided by x minus 1. So we want to evaluate this function as x tends to 1. Okay, so what do we do? Now, generally speaking, there are different ways of evaluating limit of function depending on the way the function comes. Sometimes direct substitution will just get you the answer. Okay, like let me give you a specific case of where direct substitution will get you the answer. Let's say we have y equals to x squared plus 3, and the question say evaluate the limit of y as x approaches 1, for example. So it means you want to do the limit of function x squared plus 3 as x approaches 1. Okay, this is a symbolic way of writing limit of a function. Okay, so this one direct substitution can work by just directly substitute your 1. You get 1 squared plus 3, and you get 1 squared is 1 plus 3, you get 4. Okay, in this case direct substitution works. Okay, however, there are some cases where direct substitution does not work, which is the case of the case of the example we have, the question we have before us. Here, if you attempt to do direct substitution, okay, you want to take the limit of this, the limit of x cubed plus 6x minus 7 divided by x minus 1 as x approaches 1. If you try to do direct substitution here, you see what you are going to get. If you do direct substitution here, you have 1 cube minus 6 times 1 minus 7 divided by 1 minus 1. So you see that you are going to have a denominator of 0. Okay, and in a situation where you have a denominator of 0, there is going to be a problem. We say the function is undefined, and the limit you are obtaining is undefined. So direct substitution does not work here. So what do you do in that case? All you need to do is just to look for a way to simplify, either factorize the denominator and see if you can eliminate common factors. Okay, which is exactly what is required in this case. Okay, now, but in this specific case, you might not be able to quickly factorize x cubed plus 6x minus 7. So that's where the idea of long division method comes in. So you quickly do a long division method to know, or you do a long division method to reduce that power 3 to power 2. So let's quickly do that. So we do a long division method. Let's say we put in the dividend inside, that is x cubed plus 6x minus 7 is our dividend, and x minus 1 as our divisor. So you start dividing. X in x cubed is going to give you x squared. Okay, x squared multiplied by this dividend, this divisor, you have x cubed minus x squared. Then you subtract. Okay, x cubed minus x cubed will give you 0. Then you have so now, since we have x squared here, so we have, it's like saying we have 0x squared up minus x squared here, so we're going to have plus x squared. Then we have then we bring down our 6x and our 7. That's what we're going to have left. Okay, so we repeat the same process again. X in x squared is going to give us what? Is going to give us x. So we multiply also, so we have x squared, that is, this x multiplies the divisor again, so we have x squared minus x. Okay, so we subtract. So if you subtract again, we have what? 0. Then 6x minus x, we have 7x minus 7. Okay, so we go one more time. So x in 7x is going to give you 7. So 7 multiplied by this, we have 7x minus 7. And if you divide this, you get 0, 0. So you will see that the polynomial that you have as a numerator is actually can be rewritten as, that is what we have here. Our y is actually x minus 1, which is the divisor, multiplied by the quotient, which is x squared plus x plus 7. Okay, that is, if these two factors multiplies, we get this numerator back. So meaning all this expression y can be written as this divided by x minus 1. Okay, so, and obviously this can eliminate this, so that our y is exactly the same as x squared plus x plus 7. Okay, now this is the limit we want to take. So it means we are not taking the limit, we are taking the limit of x squared plus x plus 7 as x approaches 1. So as x approaches 1, we just do direct substitution, since direct substitution can be done as I've explained earlier. So 1 squared plus 1 plus 7, which will give you what? Which is going to give you 1 plus 1 plus 7, which is 9. So the correct answer is option A in this case. Now the second question, also very similar to what we have earlier, but this one is even much more simpler. So what do we need to do? The same approach. If you try to do direct substitution for 2, if you put 2, substituting 2 directly here, you get 2 squared, and substituting 2 here, you get 2 squared, 2 times 2, which is 4 minus 4, which is also 0. So that means you need to look for a way to rewrite the entire expression, which is very easy. So if you open your eyes, you see that the numerator can be factorized. Okay, and we need to look for two numbers that multiplies to give 12x squared minus 12x squared and they had to give plus 4x. So and I think that is obviously going to be x squared minus 2x and 6x minus 12 all over x squared minus 2x. Actually, in this kind of case, it's easier to factorize. Whenever the coefficient of x squared is 1, it's easier to factorize. And the factor will always be, just open your brackets, put x here, and the two factors we have discovered is minus 2 and plus 6. Just put minus 2 and put plus 6. It's easier to factorize when the coefficient of x squared is 1. Okay, so then you divide by. Now observe that the denominator can also be factorized. X is common, so you can bring x out so that you have x minus 2 left. Then obviously you see that x squared, x minus 2 and x minus 2 can eliminate. Then this function will reduce to x plus 6, okay, by x. So you now do our direct substitution now. So we just directly substitute 2 here now. So if you directly substitute 2 here, put in 2, then we have what? We have 2 plus 6 all over 2, which is 8 divided by 2. And 8 divided by 2 will give you 4. So the correct answer is also option A in this case. Now moving on, this is also a question on limit, and you can do exactly what we have done in the first two cases. Okay, the same approach. Just try to reduce this expression. Um, try to factorize the numerator, or use the denominator to divide the numerator. Just using the long division method, then you eliminate, then you substitute the limit as x goes to 2. So I will leave this for you to attempt. So do this and drop the answer in the comment. Okay, now this is one aspect of what you are supposed to, as we have said. If you check the scheme of work, let's go back to that scheme of work or the syllabus. You will see that it was explicitly mentioned that you must be able to do limit of function. So that has been taken care of. Now let's proceed. Let's now proceed to differentiation. Now, differentiation. You are supposed to be very much familiar with some common differentiation of functions. For example, you must be able to differentiate algebraic expression. Generally speaking, if you have um, a function y, let's say y is equal to ax raised to power n, okay, and you want to differentiate is like you are finding the slope of a curve. Okay, you remember from your basic maths that slope is always changing y over changing x. Okay, but in this case, the symbol we use for differentiation is the y, the x. So differentiation of a function that is algebraic in this case is the numerator. This the power is going to multiply the coefficient here. So you have an, then you reduce the power by 1, so n minus 1. A typical example, let's say we have y equals to 8x squared, or 8x raised to power 5, and you want to differentiate this. To find the y dx here, the y dx is just going to be what? The 5 multiply the 8, then you reduce the power by 1, so 5 minus 1. So it's like you're going to get 40 x raised to power 4. Okay, so that is a basic idea of differentiation. So let's keep this in one corner. We're going to keep it in one corner, that whenever you want to differentiation of, let's say we have y, and let's say our y is in the form of ax squared or ax raised by n, then the y dx is an x raised power n minus 1. So some other very common differentiation that you are supposed to be familiar with is, you must know the differentiation of some um, trigonometric function, like differentiation of sine x. If you differentiate sine x, you get cos x. Differentiation of cos x. If you differentiate cos x, you get minus sine x. Okay, and if you differentiate tan x, you get sec square x. Okay, if you differentiate um, exponential x, you still get exponential x. If you differentiate ln x is also written as natural log of x. If you differentiate natural log of x, you get 1 over x. So you should be familiar with this common um, differentiation. You should be familiar with it. So now, the first question we have here is, they say find the derivative of y equals to x to the power of 7 minus x to the power of 5 over x to the power of 4. Now, this is a very simple. In just less than 10 seconds, you can figure out the answer to this. Why? Because if you look closely, you see that this function can actually be factorized. X to the power of 4 can be factorized out. Then you'll be left with x to the power of 3 minus x to the power of 1 here. Okay, all divided by x to the power of 4. So this is a very simple differentiation because x to the power of 4 can eliminate. And if x to the power of 4 eliminates, so it means your function y can actually reduce to x to the power of 3 minus x. So differentiating x to the power of 3 minus x is, you want to find the y dx. Okay, so all you need to do is to take the y dx of each of the function. And as we have said, if you want to differentiate x to the power of 3, this 3 will multiply the coefficient 1 that is here, such that we get 3x. Then the power will reduce by 1, so it will now be 2 minus. Of course, this is x to the power of 1. So it's like saying 1 will multiply this, then you reduce. So let's still write it. But subsequently, you should know that when you differentiate x, you just get 1. But let's do it step by step. So it means 1 will multiply x. Then the power 1 that was here before will now reduce. It will now become 0. Okay, and if x raised to power 0 is going to be what? It's going to be 1. So it means the y dx is actually 3x squared minus 1. 3x squared minus 1. Okay, so which is the correct answer is option C. So it's as easy as this. It's as easy as this. Now, without wasting time, let's move on. Now, before we solve this particular question, there are some concepts of differentiation that you also need to be familiar with. So I'm going to quickly explain them. Now, you should be familiar with, there are some cases of when we have functions multiplying themselves, or when we have functions, two different functions dividing themselves. A typical example is like this case we have x, we have x, or we have sine x minus x cos x. So if you look closely, you see that this is a function x multiplying another function cos x. So this is a product of function. So whenever we want to deal with this kind of case, all we need to do is use what we call the product rule. So there are some rules in differentiation that you need to be familiar with. Okay, the common rules in differentiation, we have the one we call the product rule. The product rule. Okay, we have the quotient rule. Okay, and we also have chain rule. Chain rule. Okay, now product rule is useful when two functions are multiplying themselves, like the case we have here now. When we have a function, let's say a particular function f of x multiplying another function g of x, we use chain rule. A typical example is x cos x, or we have 4x multiplying 3x squared plus 8 all raised to power 3. In this case now, it is a function 4x multiplying another function 3x squared plus 8 all raised to power 3. In this case, product rule is needed to solve this kind of case. Okay. Now, when do we use quotient rule? We use quotient rule when two functions are dividing themselves. We have a function f of x dividing another function g of x. So in this case, we use quotient rule. And what is the quotient rule? Yes, before we go into those rules, let's first of all define them. So a typical example is when we have, let's say we have x squared divided by sine x. I want to differentiate this function. Okay, the right approach is to use quotient rule. And when do we use chain rule? Chain rule is used when we have a function of another function. For example, I have a function, generally let's say we have a function f, a function of which is a function of g of x, which is another function. A typical example is, let's say I have sine of 4x. 4x itself is a function. Then sine of the function 4x. In this case, this is a function of another function. So in this case, we use the chain rule. So what is the product rule? Generally speaking, if you have a function y equals to v times u, where v is a function and u is also another function. So how do we deal with this? Okay, the rule stays the y dx, the y dx is you hold the first function and you differentiate the second function, minus you now hold the second function and you differentiate the first function. Okay, with respect to whichever variable you are dealing with. So let's say it is with respect to variable x now. So if it is with respect to variable x, so that means it's the u dx we are going to do, and this is the v dx. Okay, so this is what we call product rule when you have two functions multiplying themselves. Okay, now the next one is the quotient rule. The quotient rule, the same way, let's say we have a function y equals to v over u, where v is a function, u is also another function. How do we deal with this? The quotient rule is, okay, the x is equals to, oh sorry, let me use the general one that is very common, which is u up before v. Okay, that one is much more common. So let's say u over v. Okay, so what do? You hold v first and you differentiate u, minus you now hold u, you differentiate v, all divided by v squared. This is what we call the quotient rule. This is what we call the quotient rule. Okay, so for chain rule, okay, what we have, for example, we have v, let's say y equals to v of u of x. Okay, and we want to find the y dx. Our target is to find the y dx. So in order to find the y dx, this is a function of another function. Okay, to find the y dx, all we need to do is we have to do the y dv, then we do, sorry, we do the y, yes, the y dv and dv dx. Okay, this is chain rule. Okay, we do the y dv, then we do dv dx. So in a case where we have function inside another function, this is how we deal with it. Sometimes we can have multiple functions, more than one functions that are function of function of function. So for us to get the y dx, we are going to see examples as we proceed. So I will suggest you take this point down, take these formulas down, as we are going to see them in application very soon. So let me take this off. Okay, so now look at the first question we have. We have differentiate sine x minus x cos x. So how do we deal with this? Of course, you will see that it is very easy to differentiate sine x, as it is exactly present in our differentiation formulas. Sine x is cos x. So if you differentiate sine x, we are simply going to get so the first difference, the y dx. If you differentiate sine x, we are going to get cos x. So the challenge now we have is, how do we differentiate x cos x? So you see that x is a function, okay, and cos x is another function. So it is function multiplying another function. So you have correctly guessed it. We are going to use what? We are going to use the product rule. So we hold x first, then we differentiate, open a bracket. We hold x first, then you differentiate cos x. If you differentiate cos x, you get what? Minus sine x. Okay, then plus. Then the second thing, you hold cos x, then you differentiate x. So if you hold cos x now, and you differentiate x, differentiation of x is 1, as we have said. Then we are done. So what do we now have? We have cos x minus so we have plus x sine x. Then we have another plus cos x. So which will eventually give us what? cos x, we have 2 cos x, that's 2 cos x plus x sin x. So oh sorry, there's a mistake here. When we are opening the bracket, we forget this minus. So minus times plus here is minus. So please, let's be very careful. Sometimes minus signs can be a very big trouble. So sorry for that. Let's proceed. So we have cos x minus cos x is going to give us what? It's going to give us 0. So we have x sin x as the correct answer. So this is just a slight error, and we have corrected it. So the correct answer is x sin x, which is option B, which is option B is the correct answer. So proceed to another example or to another question. Now, what do we have here? So find the derivative of y equals to sine 4x. The derivative of y is equals to sine 4x. Okay, this is a function of another function. Obviously, this is a function of another function. That is, what we have here is y is sine 4x. You will see that 4x itself is a function and sine is another function. So how do we deal with this particular case? As we have said, okay, all you need to do is first you have to divide the x. First, you differentiate the outermost function first. If you differentiate the outermost function first, if you differentiate sine 4x, what do you get? You get cos 4x. Okay, then you now differentiate 4x. What do you get? You get 4. So your answer is just going to be 4 cos 4x. Okay, a much more stepwise way to solve this is better, very fast way to solve it, but a much more stepwise way to solve it is to say let the inner function be another variable. Let u represent 4x. Okay, meaning we have y is now equals to sine u. Okay, so now we need to do the y du. Okay, if you do the y du is going to give you cos u. Then you keep that. Then you now do the u dx. And what is the u dx? The u dx is going to be 4. That is, if you differentiate this 4x, you're going to get 4. Then for you to get the y dx, you need to combine y du and the u dx. So it will be as if this one cancels out this one so that you can get the y dx. So correctly give us what? Cos u multiplying 4. Okay, which is the same thing as 4 cos u. And what is our 4 cos u? What's our cos u? Cos u is 4x. Okay, but it's always better to be fast because time is not on your side. You don't have all day, so you have to be very smart. So just differentiate the entire function. Sine 4x, you get your cos 4x. Then you differentiate your 4x, you get your what? You get your 4, and you move on. So that the correct answer in this case is option D. It's option D. So that is that about that part. So let's see which other question do we have. Good. This is yet another question. This is obviously function of another function because we have cos 2x. 2x is a function, cos is a function. So function of inside another function. So how do you do this? Very easy. Okay, we differentiate cos 2x, and don't forget, how do we differentiate function of another function? Differentiate the outer function of x. If you differentiate cos 2x, what do you get? You get minus sine 2x. Okay, then you differentiate 2x. What do you get? You get 2. So eventually you multiply by that 2. Okay, then minus differentiate sine 2x. Yes, you get correctly it is what? Cos 2x. Okay, then you multiply by the differentiation of 2x now is 2, and you are done. So just open up the bracket. You have minus 2 sine 2x minus 2 cos 2x. Okay, and you see that minus is common, so you can factorize minus out or minus 2 out. So if you factorize minus 2 out here, you are supposed to have minus 2 into bracket sine 2x plus cos 2x. So this is the correct answer. So I don't think there is this is the closest to the answer, but I think a 2 must be missing here. Okay, a 2 must be in here. So with a 2 here, it means A will be the correct answer. Okay, so we proceed. Now, the next question we have is y equals to x sin x. I'm going to leave this one for you to do. This one is very similar to one of the questions we have solved. I'm going to leave this for you to attempt, and you drop the answer um, in the comment. Okay. Now, this is yet another question, and if you look closely, you see that this is on uh, product rule. It's a question on product rule. 2x squared is multiplying 2x minus 1. Even though, since this binomial, this 2x minus 1 doesn't have any power, okay, it is easy to open the bracket. And in the case where you can always open the bracket easily, I personally used to advise to quickly open the bracket easily, because it will be easier than applying product rule. So in this case now, it is easy to open the bracket. So, and since it is easy to open the bracket, we are going to do that. So if you open the bracket, you are going to get 4x to the power of 3 minus 2x times 2x squared times 1 will give us what? 2x squared. So you can easily differentiate this. So we want to find our dy dx. So what's our dy dx? Our dy dx is going to be 12x to the power of 2 minus 4x to the power of 1. Okay. Then we substitute 1. We substitute minus 1. So we have 12 into bracket minus 1 all squared minus 4 into bracket minus 1. So that will give us what? 12 plus 4, which is 16, which is going to give us 16. Okay, so we are going to stop here. There's going to be a second part of this video that talks about some other questions and um, application problems on differentiation. So see you in the second video.